This sand isn't special. You could find it on any beach. But there's a $5 liquid that turns it into this within a few hours. A solid block that, under the right conditions, withstands more pressure than concrete. No kiln, no cement, no machines. Industry has known about this for over 100 years. So why isn't your house made of sand and one cheap liquid? The answer isn't a conspiracy. The answer is far more interesting. To understand it, we first have to see exactly what's happening. Remember this moment, because what follows changes how you see building. It all starts with a liquid called sodium silicate. People call it something simpler, water glass. It's made by melting sand and soda at a very high temperature. The result is a thick, transparent mixture that behaves strangely. When you mix it into sand and pass carbon dioxide through it, a reaction happens. The silicate turns into a hard gel that binds every grain of sand. The gel hardens, and loose sand becomes a single piece of material. But here's the first surprise. This isn't some new technology from a lab. We've been using it for decades, just not where you'd expect. The answer hides in metal foundries, where molten steel is poured. To cast hot metal, you need a mold that survives extreme heat. Molds made of sand bound with water glass do exactly that. They're hard enough to hold their shape even under the weight of molten metal. So the technology is proven, industrial, and it works every single day. The material is strong, it holds its shape perfectly, it handles the heat with no problem. It all sounds like a ready-made replacement for concrete, doesn't it? But this is where a problem appears that breaks the whole story. And that problem is something that falls from the sky every day. Remember that number about strength? It's true, but only in dry conditions. The moment a block of sand and water glass meets moisture, it starts to weaken. The sodium in the mixture loves water and pulls moisture right out of the air. When moisture enters the structure, the bond between the sand grains gives way. Tests show a dramatic drop in strength after just 24 hours in humidity. In the worst case, the material can crack and fall apart. Now imagine a house. Rain, snow, moisture from the ground, for years. A material that softens the moment you splash water on it isn't a builder's dream. That's why engineers say, excellent strength, but poor moisture resistance. But here, the story gets smarter, because the problem has a solution. Scientists discovered that the right additives change everything. Lithium, zinc oxide, or special organic compounds reduce water absorption. The higher the silicate modulus, the more resistant the material is to moisture. With the right tuning, a block can stay solid even underwater. So the problem is solvable, and that's great news. But every solution adds cost and complicates production. And while some are fixing water glass, others took a completely different path. A path that uses something alive. This version is called biocement, and it almost doesn't sound real. Imagine turning sand into stone using bacteria. There's a bacterium called Sporosarsina pasteurei with a special enzyme. That enzyme, in a calcium-rich environment, produces calcium carbonate. And that's the same mineral limestone and marble are made of. The bacterium essentially glues sand grains together with natural cement. Within a few days, soft sand becomes real, hard stone. And the best part, this stone is naturally resistant to water because it's made the same way nature has made stone for millions of years. Eco-friendly, strong, water-resistant. So where's the catch? The catch, as always, is money and scale. Bacteria need food, urea, and time to do their job. For a small sample in a lab, this works perfectly. But construction demands enormous quantities, fast and cheap. Growing bacteria and controlling the conditions make everything slower and more expensive. That's why, for now, biocement loses the race against cheap concrete. But scientists aren't giving up because they see where this truly shines. And that place might not be the one you'd think of first. One of the strongest applications of biocement is deep beneath us. In mining and drilling, bacteria can solidify sand underground, so that tunnels and boreholes don't collapse or cave in. In theory, we could even solidify the seabed before drilling. Where digging is dangerous, this method brings stability. This isn't a replacement for concrete in your backyard. This is a tool for places concrete struggles to reach. And there's one more place where biocement beats concrete convincingly. And it's hundreds of years old. It's about the restoration of historic buildings and monuments. With old walls, ordinary cement creates a serious problem. Cement traps water behind it and, over time, cracks and crumbles. Biocement, on the other hand, lets water pass and breathes like natural stone. That's why it's far safer for repairing ancient structures. Imagine saving temples and fortresses using bacteria. The past repaired with the same chemistry nature builds it with. But now we have to return to the main question. If all of this exists, why does concrete still rule the world? The answer isn't that someone is hiding the truth. The answer is a sum of practical reasons. First, concrete is incredibly cheap and available everywhere on the planet. An entire industry, its machines, and its regulations has been built around it for 100 years. Second, concrete is predictable. We know exactly how it behaves over decades. New technology has to prove its reliability before we trust it with bridges. Third, building codes are strict and change slowly. No city allows a building made of an unproven material, so no one is hiding this. It simply doesn't win at everything yet. But that doesn't mean it has no future. Quite the opposite. The future of these materials is specialized, not universal. Water glass will keep ruling in foundries and special industries. Biocement will grow in mining, monument restoration, and green construction. And researchers work every day to make them cheaper and faster. Maybe in 20 years, part of your house will be bound by a bacterium. The real story isn't a magic liquid from an ad. The real story is better. It's the story of how science, step by step, turns the impossible into the ordinary. Sand is the most abundant material on Earth, and we're only just learning to use it. And once we master that, the way we build the world could change forever. And here's what most people don't realize. This isn't a distant dream. It's already happening in real factories right now. A North Carolina company called Biomason grows bricks instead of baking them. They feed bacteria, calcium, and water, and loose sand hardens into solid stone in 3 days. No kiln, no flame. The whole reaction runs at room temperature. Their bricks are said to be lighter than concrete, yet several times stronger. And because there's no furnace, the process cuts carbon emissions by up to 90%. In the Netherlands, a company called Green Basilisk went even further. They put limestone-producing bacteria directly inside concrete. When a crack forms and water seeps in, the bacteria wake up. They produce calcium carbonate and seal the crack on their own. Concrete that heals itself, like living skin closing a wound. These aren't lab fantasies. They've attracted tens of millions in investment. The goal is bold, to erase 1/4 of the concrete industry's carbon footprint. So the question was never whether this works. It already does. The real question is how fast the rest of the world catches up. Thanks for watching all the way to the end. It really means a lot. If this was useful, drop a like. It helps more than you'd think. And subscribe, because there's always another forgotten trick coming. See you in the next one. And don't forget to leave a comment and share this with your friends if this content helped you in any way. Take care.